Alright, Mastering SolidWorks, Chapter 22. Working with large-scale designs. According to SolidWorks Marketing Materials, large-scale designs bring together the tools you need to effectively design machinery, heavy equipment, plants, small ships, or other large objects. Large-scale designs encompass the topics exclusive with discovered in this chapter: walkthrough, animation, grid systems, IFC export, large design review, facility layout. Although large-scale designs also standard SolidWorks functionality such as sketching, part modeling, assembly modeling, weldments, drawings. These later topics don't have the large-scale design specifically compatibilities at this time. In this chapter, you will learn to understand large-scale, use walkthrough, export IFC, create a grid structure, layout facility, use large-scale design review. Using large-scale design review. Large-scale design review is view only made enables with the perform design view activities with large assemblies. You have access to following features in SolidWorks: Feature Manager, Measure Tool, Section Tool, Hide to Show, Assembly Expert Walkthrough, Large Design Review, Tab Command or Manager. Large Design Review, you do not have access to these features. Assembly Feature Component, Part, Patterns, Mates, Dynamic Assembly Motion. Assembly tab of the Command Manager, change components property, change configuration of LDR, large design review. Mode: to open assembly, a large design review, open the dialog box. In the mode drop down box, select large design review shown in figure 22.1. Open dialog, open assembly, large design review model. So we were going to open a file. We've now moved from mode to large design review. Figure 22 shows the dialog box welcomes you to large design review on the left, large design review feature manager on the toolbar on the right. One of the things that has been removed with this window is some of the illuminations work with the new tool. Important to know how you'd expect to go about it. The window does suggest that you have to look in the help for more information on limitations. However, the linked help page does not directly list limitations per typical SolidWorks method handling such things. You are on your own to discover the boundaries of what you can and cannot be done. For example, large design review is stripped down interface, but it will help you to look at simplified data sheet set. For this reason, if you don't enable what you're doing, everything you can do in the full SolidWorks interface, sometimes the tools will be missing. You can see assembly features that are mates, some fancy visual effects of real view, shadows, reflections. Some of the materials will be also missing. Also, things like rebuild and force rebuild will not have any effect. 22.2 shows the large design review enables you to review large assemblies more quickly. Open review large assemblies, quicken view only mode with relating to the capability to navigate feature design trees, selective opponent, open components, measure distance, create cross sections, hide show components, create walkthroughs. Large design review interface appears in figure 22.3. A review, and it shows the sub-assembly parts, and you've got a Tonka truck there. Updating large design review components within assembly of the large design review can be out of date due to the change with other components. To be notified when parts or update, you can use system option, tools option, assembly, automatic check, update all components. You may also need to update component after assembly has been opened with large design review options. Do this are available the right mouse button within the large design review. Assembly figure 22.4 shows some of these options. Alright, so we're in 22.4 shows outdoor components and how update works. Shows invert selection, subassembly selection, tool, zoom, pan, recent commands, update, hide others, isolate command. If you're working on a model, you can someone else is using large design and has open large design review. Make save change. You'll get a message that warns you the situation, gives you the option to update large design review. Graphics is shown in figure 22.5. Resolving components, large review, lightweight mode, gaining full editing capabilities to part within an assembly requires resolving the component. To do this, you can use selective open or set all options shown in figure 22.2. Taking snapshots. Snapshots are custom name views, features, scenes, lights, and cameras tabs of the display manager. One of the difference between a snapshot and a custom name view is that hidden parts remain hidden in a snapshot. So that's the picture over here, the snapshot. Remember that the hidden parts remain hidden in the snapshot. You can access snapshot tool with a view toolbar through the menus views, light, and camera. Tag snapshot through default hotkey alt spacebar. When you take the snapshot, SolidWorks asks you to name it just as a common custom name view. Figure 22.6 shows snapshot saved display manager. Alright, home snapshot is the default configuration automatically created if you open the assembly in the large design review. Alright, with a guy walk with an arrow forward, walking through. Walkthrough is a method to create animation simulation when a person would see as he walks through large-scale design. Chapter looks as example the very large dump truck. Turns out the good example of equipment design where walkthrough could be useful in Figure 22. 7 shows the walkthrough area display manager along with the model used for this example. You can do walkthroughs using interface to direct an avatar virtual mannequin, or you can drive the camera along a sketch path. Sketch path method has some overlap motion manager animation, which is covered in Chapter 23 animation with motion manager. The interface walkthrough consists of 2 elements: initial setup of the control by walkthrough property manager shown in Figure 22.8. In property manager, you can select a base plane which acts as the floor, then establish a camera height to simulate the height of your eyes off the floor. You're intended to drive the walkthrough with the sketch. You can select the sketch element with a motion constraint selection box. For the most fluid motion, use splines. You can use 2D and 3D sketches. Start walkthrough. Click the Start Walkthrough button on Property Manager, and interface shown Figure 22.9 will appear. Alright, 22.7 shows using Display Manager managing walkthrough. We click this little scenes and highlight camera. Shows the walkthroughs with the guys through it. Walkthrough, Property Manager, Start Walkthrough, Play, Record, Generate View. View settings, top, flip direction, distance from the surface, motion constraints up and down, turn avatar, undo file paths, treat surfaces and infinite planes. 22.9 infinite walkthrough interface helps you manipulate the view of the motion of the camera. Capturing walkthrough requires an interface significantly different from the other SolidWorks shown in Figure 22.9. Although interface in the documentation referred to as avatar, you won't notice that any of the sort of the virtual mannequin walking through the model except in the SolidWorks sales demonstration. When you get the mode, scroll wheel of the mouse works backward in standard SolidWorks functionality for zooming. You can also turn the walk and you cannot turn walk. You also cannot turn and walk at the same time. This feeling is very much like an early 1990s primitive video game. Workflow to create workflow goes like this: some suitable model, preferably something interior you want to virtually wander around inside, works best in model scale buildings. Click the Display Manager tab and the Feature Manager. Enter scene lights, camera buttons. Right click walkthrough entry, and this select Add Walkthrough. 5. Establish floor vertical direction. Tell which is end up literally. Also establish the height of your eyes above the floor. If you're using a sketch path, select the sketch segments and motion constraints and selection box. Press capture on the walkthrough of your walkthrough. If you're using sketch to drive the motion, use the forward button on the interface camera will walk along the path. If you're not using sketch, use the arrows interface to make the camera called an avatar interface move. 8. Generate and save video. Dump truck files. I used example of the download materials from Wiley website. The good model for use to practice creating a grid system. SolidWorks, a grid system in 3D sketch repeats 2D sketch on every level of the structure. You start with a 2D sketch where lines present structural members from the level. SolidWorks uses derived sketches on the plane. 3D sketch itself contains only columns. The structure could be bolted together in fabricated I-beams, weld the tubing structure, and assemble scaffolding, for example. Grid systems can help identify interior-exterior wall structural columns, beams. Figure 2110 shows complete grid system. Here's a basic workflow of creating a grid system. Click Grid System button on feature bar with the Insert Reference Geometry menu selection bar. Draw a sketch and represent the outer shape of the structure as well as the inner structure members. Use the grid system property manager to establish number of level the floors, the default height of the levels, specific height of each level. Click OK property manager. Watch the SolidWorks build the grid system. Each step includes some detail, requires more explanation as it makes to make it work. Figure 2110 shows grid system in SolidWorks message. Number of parameters, distances, level, number, heights, 3D sketch splines, auto number balloons. Hard to grid with a 3D. The grid system toolbar icon listed part of the feature toolbar, although it's not here with the default. If you want to add a grid system icon to any toolbar, tools, customize command, select it from the end of the list icon feature toolbar. You can access grid system through menus default with a different location through menus insert reference geometry grid system. Creating the sketch. When you start with the grid system feature, SolidWorks puts you in the 2D sketchtop X and Z plane that provides no other explanation. Software waiting for you to create a sketch with some properties. Sketch essentially represented the layout of the structural members from level 1 level structure. 21 and 11 show the sample sketch. 21 and 11 is a sketching sample structural layout. Sketch dimensions in inches, but you can also appropriate units such as feet or meters. Notice all the annotations label intersection lines with the letters X direction and number Z direction. Structural engineers use this method to identify the columns in the structure. Column in the center of the sketch is shown in figure 2111 would be called 1B. The column line labels the automatically generated SolidWorks with auto number balloons option bottom of the grid system. Property manager is turned on. Several rules of sketching are not obvious. First, all lines are planar, either horizontal or vertical within the sketch. You cannot make a circular structure and use this sketch to lay out something like a power line tower, or you might be able to add additional diagonal members later, but you cannot use them as part of the initial layout of the grid system. Using Grid System Property Manager. When finished with creating the sketch, they exit the sketch using the sketch icon in the confirmation corner up right hand of the graphics window. Brings the Grid System Property Manager as shown in figure 2211. Everything in the Grid System Property Manager seems self-explanatory. The default level is 118.1111023622 inches. In conversion, the default 3 meters high, then 3 meters SolidWorks uses. Notice that you can customize heights of each level. For example, if level 3 has some specialized equipment that needs some more room, standard level height, you can easily specify the part of the design. Setting 3D sketch split lines controls whether the columns are extended through the level of the grid, where continuous top and bottom, and whether they will be split at each level. Which option you select mainly depends on what you plan to do with the grid system. If you plan to either create a weldment, you may want to split the lines. If you plan to simply extrude the shape the entire height of the structure, you may prefer not to split them. Understanding the grid system output. Grid system creates a single feature manager with a number of derived sketch planes as shown in figure 2212. Additional features are listed in parents. Grid system intended below in the feature manager. 2212 shows listing of grid system options. Shows 3D grid right here. I've already noted the derived sketching planes, one each per level. Created an appropriate height. The derived sketch for the parametric copy of the original sketch placed on a different plane with the original sketch copy. The derived copy of the also up-to-date derived sketch can be moved, rotated only. They cannot be edited. All changes must be performed on the parent sketch. The 3D sketch feature manager contains lines forming columns, y direction lines between levels. Sketch is hidden in the default. You may also notice that the grid system uses the transparent surface represented the interior-exterior walls. They are hidden in the default depending on the structure. You may or may not have any of the use for the operation information about the walls. You may care about only the external walls. When you're using the grid system, interaction surface is limited to showing and hiding them. You can also see the display pane on the right mouse menu button to do this. Viewing grid components, right-click on the grid system feature for the feature manager. Select the name of the view grid components. These are useful. Creating a weldment for grid wants you to see a list of features of the compromise of the grid itself, rather than all the weldment features. View the grid component. The dialog box shown for 2213. Isolating grid components, separating windows, surface body, grid system sketches, 3D sketch, surface extrude sketch. Transfer data IFC file. IFC stands for Industrial Foundation Classes, which is developed with the IAI, International Alliance for Interoperability. As open data exchange format, it meant to be used as transfer data building modes between building information models, or BIM, software packages. ArchiCAD and Revit are two examples of building information modelers that might use this type of information. The Industrial Foundation class file types include geometry, but also can include non-geometrical information about the functioning occupant spaces within the building. We can find that these abilities to transfer, which cause SolidWorks custom property information along with the step file transfer. Although use of SolidWorks and AEC realm and limited to the SolidWorks firmly established equipment design closely related to design plants, industrial steel frame structures. To save a grid system as an industrial foundation class, click Go to File, Save As, drop down list IFC file type. You can also select Options button of Save As dialog box to set the units of Omni class as shown in Figure 2214. Alright, Omni class configurations give the detailed structure classifying with the data prior to importing the building mode. Software such as SolidWorks would be useful in small component buildings rather than building itself. With equipment produced in SolidWorks could be still used in a BIM, building information model, air conditioner equipment, windows, plumbing, and other component hardware would be commonly created in SolidWorks. If you want to learn more about industrial foundation classes standards, refer to the following website, which has a detailed description, structural purposes, history of the file type, aecbytes.com, feature 2004 industrial foundation classes HTML. Saving data industrial foundation classes file, save type IFC4 or .ifc. System options, file format, Omni class, common property, uni class, material mass prominent units, export, BREP, Teslization. Alright, the bottom line, SolidWorks has long been used the design equipment and components to get into the building. Large-scale design software also works to design small plants, grid structures, walkthrough capabilities. Large-scale design uses some animation capabilities. An industrial foundation class export options allow all users to share SolidWorks large-scale designs within building information. What is that? I believe one more time. Building information model. Software users. Master it, large design review. For example, the dump truck solid assembly model that is included with the download materials for this chapter. Also, open the same model and standard SolidWorks. Familiarize yourself with the difference between the two. Master again, use the dump truck model to make a walkthrough. Use either the manual control with the 3D sketch path to direct the walkthrough. Master it, start a new part with open the grid system feature layout with the restore structure holding process equipment when spacing between the first two floors is 10 feet and spacing between floors 2 and 3 feet. 2 and 3 is 12 feet. Chapter 23, animation with the motion manager. This is what I wanted to get to.